Hello, hello, hello. Cheers, Kevin here, and welcome back to Minecraft Agoraphobia, the game where we do not leave the house. Pretty much. That's all that can be said for this game. We have not left the house since we built the house, but we do have a robot friend that will leave the house on our behalf. Wonderful little Vinny here. I can go ahead and click on Vinny, and we have, oh look, we just happen to have this script open. This is a script that we used to actually have Vinny fetch us some water. So now we have all of this wonderful water over here, which we can renewably steal from and put back. So thank you very much for that, Vinny. Now, it's been a few weeks. I want to mention that if you're watching this series, this is going to be a little bit more slow-paced than you might desire or prefer, but that's because we're still learning Lua. Ideally, once we start to build up some libraries, things will be a little bit more fast-paced, but right now we are kind of dealing with the bottleneck of just getting ourselves kind of the bare minimum libraries that we want to have to be like, hey, maybe walk over there. And in fact, if we open up Vinny, we can take a look at this is the script that we used to have Vinny get us some water. It swung down, it went down, it swung down, it went down, it placed up, it turned left, it swings, it's forward, it went forward, it swing, it went forward. All of these things. That's a lot for it to worry about. And this is just getting itself out of the house. And in fact, we can go ahead and run this. Let's go ahead and run this real quick. We'll go ahead and just say water. And there you go. He digs down. Of course, he doesn't have a bucket, so actually this may have been a mistake. This was probably a mistake. Oh no, I've made a terrible mistake. He goes over there. We can watch from the window. He's turning, going down, and tries to fetch some water. And then comes back. And just these single lines of move forward, move forward, move forward, move forward, etc., etc., etc. There we go. And then digs down, comes back up, puts a block down, and turns around. And there we go. And if we go ahead and edit that file again, we can say, yeah, this is 62 lines of code. Get inside the house, and then we have basically just manually undoing all of those steps that we took in the past. So it's a lot, and what we want to do is try and build things up on our own to improve this, because right now, what we need, in addition to, eventually doing some farming and all that sort of crazy stuff, it'd be good to get some wood. We'd like to at least get some saplings and start planting a couple of trees so that we know we have that available as a renewable resource for us. Now, in the last episode, we spent some time talking about writing code in an external environment, and we laid the groundwork to be able to do that. And so I'm switching over to a Linux virtual machine right now so we can take a look. So this is kind of where we left things off. I could be a little bit off about where we left things off at the end of the video. But we have, ideally, we were talking about, so actually this will show all of the code that's currently on that robot. This is the example code that we just ran. Local robot equals require robot, which is a thing that we get from the mod. And then we have all of our manual code that we wrote, getting out of the house. Swing down, which is use your tool and point it downward, and then step down and do that over and do all of these things to navigate our way over to that water supply. Ideally, we would like to have a different sort of syntax. We'd like to create our own library on top of that calls things. So it would say, all right, so let's say we have a function called go, and we give it a path. So there's our function. We split that path into tokens. So a path may look like this. F4, that means go forward 4 spaces. L, so turn left. F, so go forward. B, go back. B2, so go back twice, and then up. And we would have to go ahead and split that string into the individual steps so that we know which commands need to be followed in order to do that. Then we would say, all right, for each of those tokens, do that thing, right? So F4, well, go robot.forward twice times. Now, Lua is a very compact language. I was asking a good friend of mine. I was like, hey, what do I use to do testing? He's like, it's mostly not there by default in Lua, and I'm going to take him at his word, which means that we're going to need a little bit of stuff to be able to test things. I can go ahead and run this. If I go ahead and clear stuff here, you can see we've got all the same files that we had inside the robot, but I can go, no, I can't run it like this, but I can run it like Lua, hello.lua, and it prints yo. That makes sense because we have print yo at the very top of the file. I've also set up a key binding to shortcut that. There we go. Yo. So there we go. And I can change this. I'm going to say, hello, Agoraphobia viewers. Well, okay, I can spell. I can definitely spell. And there we go. Hello, Agoraphobia viewers. And this means we can really rapidly work on things and improve the code that we're writing. Of course, it does mean that we're not going to be in the Minecraft world for a little bit because we are going to be working and kind of building a quick library that we can go ahead and test to do this. So let's imagine that we want to have a library that will do this for us. Now, what is that going to look like? Well, I have below this function go, I want to try and do this in a test-driven way. And that means that we're going to use tests to drive how we write things. And here's an example. Go calls robot functions. That's a bad test, actually. I'm going to nuke that example. I'm going to leave it there for a moment. What I want to do is write something like this. Test robot. Let's see. What we need is some sort of name for our own module. Something that's not robot, but is something that is greater than robot. Let's call it Android. There we go. That's going to be the name for our library. It's going to be a smarter thing that calls some of the robot functions, but is cleverer about it. So while we do have, by default, we have, robot.forward and robot.swing that we get from their library. Oops, what am I doing? Robot.swing that we get from their libraries. Robot Android may be like Android.move forward 4, or whatever the case may be. So we're going to use tests to help drive the development of our library, because then it means that we're not writing a bunch of extra code that we know we're not going to use. And we're not going to find ourselves in the middle of writing code going, how exactly do I want this to work? Should we change the arguments that this thing takes? We're going to have the use case in the actual code itself. So, well, rather in the test itself. So let's go ahead and write a test real quick. I'm going to Android, let's see, Android move calls robot functions. That's a fairly nondescript test, but that's fine. We're going to give it a comma. And let's see, how do we give it a function? This is part of the thing is I'm not super familiar with Lua. I think I can probably, well, let's see. Whoa, okay, I've got a bunch of stuff open. Sorry about that. I meant to check that. All right, Lua, anonymous function. That's fine. We're going to learn stuff here. Functions are anonymous. Cool. AP, anonymous. Anonymous. They do not have names. Right, anonymous functions equals function X. Cool, perfect. So we'll have a function. How do we have a multi-line function though? Oh, I guess we just, function ends with the keyword end, I guess. There, okay. Whoops, no, what? Come back. Hello. Actually, we should rename this, shouldn't we? We should rename this to, we should rename this file. We're going to rename it so that we know what it is. I'm going to rename hello to android.lua, and then we'll go ahead and open that up. And we're just going to go ahead. So I'm going to say that this is going to be, we'll put this over here just for reference as far as, I think the syntax is totally wrong, but that's fine. We're not going to worry about that. Android move calls robot functions. Now, the idea with test-driven development is that you do three things. One is you write enough test to make the code fail, right? Then, once the code fails, you'll say write enough code to make the test fail. Well, I mean, to make the test fail either way. There we go. To make the test pass. And then, optionally, refactor a little bit. And then repeat. This is all that we have to do. We're just going to write just enough of our test code so that things break. And we go, oh no, I need to write some code to make sure that this thing works. As soon as it breaks, then we go, okay, well, I need to write some real code to make, So we're going to make sure we write enough tests to make things break. Once we have things, then we go, oh no, something's broken, I fix it. Once we fix it, we'll go, all right, well, cool. I need to write more tests so that it breaks again. And you just kind of go back and forth. It's like accounting where you keep the double ledger bookkeeping, double bookkeeping, something. Let's go ahead and see what happens here. Now, there's a problem in that, and that is that test doesn't exist. So I'm already predicting this is totally going to fail, even though we don't have anything in our test body. It's not actually testing anything. We're just trying to define a test, and right now that does nothing. We're going to actually have to write our own little test library. So let's go ahead and try and run this and see what happens. There we go. Attempted to call a nil value, global test. Fine. Let's go ahead. Okay, so well, that's good. Even though we don't actually have a valid way to write tests, where we have a test, we have this block of test code that is broken. And so, okay, well, that's fine. We can go ahead and define something. So we'll say, let's see, global test equals function. And let's just see if that works. Syntax error near test. Okay, so no, local test equals function. Okay, there we go. Things pass. And I wonder if we can get rid of this local. Oops, because I think global may be by default. All right, cool. That's probably fine. Okay, so now things fail, and now things pass, or at least they don't error out. I want to put in here, I'm going to say assert false. That should be enough to cause this thing to break. Except it doesn't. It doesn't break. And in fact, here, this function is not going to get called at all, because test doesn't use it at all. Test takes in 2 arguments. It takes in a name. We're going to cheat a little bit here because we're building our own test framework. We're building a really dumb test framework, but I'm going to call the function fn. So if you look here, we're saying test, and we're passing it 1, the name of the thing that we're testing. Shoot. No. What? Fine, whatever. There we go. Yeah, the name of the stuff that we're testing, and then we're passing it a function that is, hey, here's the actual code that you should test. So we're giving it those 2 arguments. What I'm going to do here is I'm just going to say call fn. We're going to ignore name. We're not going to do anything with it, but we're going to go ahead and we're going to say, okay, here we go. And there. Now we finally get an error. Assertion is failed. Now that's pretty cool because assert is available to us through Lua. And we don't have to write our whole like, hey, check this thing. And if it's not true, then, then throw some sort of error. We already get it. And we have a failed assertion. So that's cool. It's not a particularly useful assertion, and we're not going to really worry about that too much. If it becomes a pain, we'll worry about that then. But we'll do that. We can actually, no, let's leave it this way. Let's see here. Actually, now one thing that I would like to have as part of our test library, as part of our super, super complex test library, is I'd actually like to output, hey, this thing passed or failed. So let's say, and there we go. We'll say done. We'll print done as part of our test. Of course, that's not going to pass. Of course, there's nothing that can make this pass because the function will throw an error. There we go. Okay, so it says done. We can see that basically if I were to running this test, we get, okay, hello Agoraphobia viewers, running this test, and then done. What I would like to have is, I wonder if there's some sort of, if there is a try catch. Let's look at that. Let's check out Lua. Let's see if Lua gives us a try catch. Because if it can catch assertions, then we can have it handle that in a nice way. Let's imagine that we had 2 separate tests. We wouldn't want to not run any tests just because one of them happened to fail. Error handling and exceptions. Error, pcall. Wait, call foo with pcall. Pcall. If you need to do stuff, then you call it with pcall. Cool. Let's change that to pcall. And then we can say if pcall function, not function with arguments, then, and if that's true, then no errors. Otherwise, errors. So what we can do is we can say if there's no errors, then print name. Let's see, print. I don't know, do I have a check? Nope. All right. Print passed plus name. Otherwise, we'll print failed. Nope, unexpected symbol. Shoot, because we can't concatenate strings that way. Lua string concatenation. There we go. Program string, but oh, dot dot. Right. Instead of plus, it's dot dot. Let's see if that runs. Unexpected symbol near dot dot. What? Oh no, that's okay. Nope. I think I'm wrong. No. Unexpected symbol. What? on line 11. Nope. All right. Interesting. All right, so maybe dot dot is wrong. Concatenation of strings in Lua. We are learning. We are going to figure this out. File name dot dot string. All right. Whoops. What? No. Oops. I accidentally opened a new thing. Okay. Odd. Well, okay. Let's try this. Dot concat name. Right. That maybe that'll be okay. Will that pass? That did pass, and then it failed. Oops. No, it did not pass. Just one dot. Okay, and now it's mad on line 15, which we can fix. Dot concat name. We'll have to spend some additional time late. Whoop, there we go. Attempt to index a nil value. Interesting. Okay, nope, that was wrong. Pairs, pairs. There's a shorthand operator. Nope. You have to type it in full. All right, now I'm very confused as to why this doesn't work. Okay, so it does look like dot dot is the syntax for combining strings. Let's go ahead and just say local str is passed. Local str equals str dot dot name. And it'll say print passed. We're not going to print out str at all. We're just going to see if this fails. Nope, that one's fine. Okay. Let's see here. str. Print str. Then syntax error near str. Interesting. Why is that the case? Lua print a string. Lua print, whoops. Lua print string. We're going to learn. We're going to figure this out. Oh, is it just the lack of arguments? Or the lack of parentheses, maybe? Yes, that's all that it was. All right, so we can just say print passed dot dot name. And similarly, we can do the same thing down here. Failed. And we'll go ahead and clean up some of this. And there we go. Passed. Android move calls the robot, calls robot functions. We can take out the whole running this test thing. Now let's assert false and see what happens. Failed. Android move calls robot functions. Cool. Now this doesn't give us any helpful errors. So is there a way for us to get those errors? Can we look at something about those errors? If pcall else foo raised an error, you can call this with an anonymous function. Status error. Aha. So we can get the error out. Let's take a look at that then. We'll say local status error equals pcall function. And now instead of calling this in line here, we'll say if status then this. And let's just double check. Failed, which is what we expect. And if we turn this back to true, and we run, then it passes. Good. And let's instead also say print error. Let's change this assertion to false so that we cause an error. Android Lua 22 assertion failed. Okay. That works for me. You know what? That definitely works for me. The only thing that I don't like is I don't like the I'm gonna change this a tiny little bit. Let's grab this check mark here. Just gonna grab this symbol because I don't remember the keyboard thing to paste it. I'm gonna go ahead and just change the message. I'm just gonna say print name dot dot space this, and otherwise we'll say print X, and we'll also print the error. So there we go. There is our very, very simple test framework. We're using assert, which is a thing where we pass it something, and we could do something else like assert 5 equals 5. I think 5 equals 5. I'm guessing, and it goes yes, that is true. Actually, I don't like that this is not distinct from the actual test. So what I want to do is I'm going to add something here. I'm going to say equals. And let's say, we'll just put a dash, dot, dot, that. We'll do the same thing here. Dash, dot, dot, that. Now we go ahead and run our test. And there we go. Okay, no, I want a space as well. We're making our test framework super, super fancy. Okay, now we see here. That's pretty good. Although, no, now I want the check marks on the left side so that they're all going to line up visually, which is going to make things shorter anyway. All right. No, I can't delete that because no, it's fine. It'll be fine, Kevin. All right, let's go ahead and paste that in. There we go. And we'll do this. Yeah, we'll just do it this way. That'll be fine. And we'll do this with an X. And there. Okay, so there we go. Android move calls robot functions. Right now that is passing. If I were to go ahead and say assert that 5 equals 6, now it is failing, and it tells us the line number where the assertion has failed. So now we have the ability to do test-driven development. We can start actually working on the thing that we want to be working on because we have written our very, very simple, admittedly, test library, and that's pretty cool. So these lines of code are pretty much could be ignored, but that's great. Okay, so we want to jump back and forth now between. Actually, I'm just going to put this up at the very top here, so we just don't have to worry about it, and I can actually take this out. What we want to do is, and we now want to bounce back and forth between our test code and our real code, right? The library that we're actually writing. What we want to test is we want to write the bare minimum to allow this to fail. And when we're writing that test, we don't need to use assert right now. We can get rid of this nothing. We want to think about exactly how we want to be able to use the library that we're writing. And what I want to be able to type is something like this. We want to find the simplest case that's going to fail. So I'm going to say android.move forward. I think that's the simplest the use case that I can come up with. I can imagine eventually when going forward to eventually wanting to say let's move forward 2 squares, and maybe once we get more complex, I say forward 2 squares and then left and then forward 2 squares. And I would have some assertions. I want to make sure, hey, if I call you like this, you better be calling robot.forward twice and then call robot.turnleft and then call forward twice. Things like that. But the simplest case, the best way to get this thing to fail is right here, android.move f. Obviously, I could get this thing to break by android.m. That's going to fail. But we don't want to be writing fake code. We want to be writing the very simplest, valid syntax that right now will cause the test to fail because we haven't written Android at all. So there we go. Attempt to index a nil value global Android. So we need to define this now. Let's go ahead and write this. I'm going to say, let's see, Android equals, I don't know, maybe this. Is that valid? Tend to call a nil value move. Okay. Function, nope. Move. I don't know how this works. Maybe like this. We'll do like that. Will that work? Name expected near function. Okay. Nope. So that's not valid. Let's see, function move. No, let's say here, local move equals function. And nope, unexpected symbol near local. Okay, let's finally look at this then. How do we create modules? I think I started pulling some of this stuff up. Okay, so yeah, networks are not. It appears that they are not like that. Let's take a look. So Lua module function. Sure, module function is great. Modules tutorial. Fantastic. There we go. Function my module foo. Oh, okay. So this is how we want to. So this is basically how we want to do this. So we'll create. We'll say Android equals this, and then we'll say function Android.move, and then we'll have end there. Okay. So we're just trying to fix the actual error that is occurring, and unfortunately, because we're getting a very simple error message that doesn't tell us very much, but. Look at that. Android move calls robot functions, and now it's passing. We've not actually implemented anything, but that's fine. All we were trying to do is make sure that we don't write extra code until we know that things stop failing. So this isn't failing because it's able to call the function and it doesn't error out. That's great. What we want to do now is we want to write some sort of assertion. What I want to do is assert robot. Let's see. I want to assert that forward was called. That's what I care about. If I say Android move forward, I want to make sure that forward was called. I have no idea what that means right now, but we'll go ahead and test that, and it has failed. Of course, that's not a particularly helpful error, but that's okay. Let's go ahead and say local forward was called, there we go, equals true. Our test will pass. Fantastic. Let's go ahead and change it to false, because it hasn't been called, and now it will fail. Now, what we need to do is find a way to ensure that we can hook these two things together. That we can actually, we don't want to add really more to our test. Right now, this test is failing appropriately, and there shouldn't be any other additional code that we should have to write, except for possibly checking, setting up some sort of thing. So what I want to say is like robot, basically we want to say something when robot.forward is called, set forward was called to true. That's basically what we need to do before we call move, so that we go, all right, I want to make sure that robot.forward will actually let us know, and it will change that thing. So let's actually do that right now. We'll go ahead and just say function robot.forward, and we'll just say forward was called equals true. And now we get an error on 23. It's mad because it's trying to find robot, and robot doesn't exist. That's okay. We'll go ahead and say robot equals this. And there we go. Assertion has failed. Sad panda. We can go ahead and actually delete this because now we've actually got that implemented. Where's the line that's broken? Line 29. That's this line here. Forward was called has not been set to true because this function, even though we've defined it, does not do anything. So what's the easiest way to make this test pass? Well, let's just say robot.forward right inside here. And now things pass just fine. And if we're doing some hacky stuff here in that we're explicitly defining what robot.forward means, but hey, that's not the worst. That's not the worst thing in the world. And we actually do have this thing working correctly. Now, of course, what we would need to do would be to define an additional test. Let's say that I pass it F2. It still passes, but we know that's an indication that our test is very brittle. What happens if I call back? It passes, but we haven't changed this. So if I say back, if we changed forward was called to be back was called, we would head change up, forward back, or robot.back does that. We can leave the variable name wrong, but that's fine. Back was called, back was called, and here, back was called. This is also a very valid test. Not bash, back. What's wrong with me? Back was called. This is also a very valid way to test the behavior that we're trying for. We want to say, all right, if I call Android move with a particular string, it should do the thing that that string says. But if we run this, nope, it is going to fail because it's calling robot forward. It's hard-coded right now. So we are going to have to stop there just because we're moving along on time. But what we want to do now is figure out how it is that we can interact with this robot library, this robot module, in a way that is actually sort of based on the argument that we pass in. Now, we run into an issue that I kind of think of as just sort of the pendulum, that it gets to the point where if we stick with this very strict test-driven development cycle of write some tests or modify some tests until it breaks, write some code until it fixes, well, we could bounce back and we could go up here and we could say, all right, well, fine, I'll just change this to back. And look, it passes. I go, all right, well, I'll go back to the test. How do I break this? Well, I'll go ahead and change all references of back to forward. And I'll go ahead and change this to F. And look, now it breaks again. Well, that's fine. I'll go up here and I will change this to forward. And now we're passing. Well, that means I have to go back to the test. And you get stuck in this infinite loop of bouncing back if you're trying to stick with very rigorous test-driven development. What instead we probably ought to do is write a separate test so that we're testing both of those behaviors. We're making sure that it can process multiple different strings and that it behaves the way that we expect. So that is something we will have to take up in the next episode. It's possible that we'll have to look at the idea of stubbing and spies. I'm not entirely sure, but we may need to jump into that. But that is it for me today. I suppose we should pop back over to Vinny just to say goodbye. So Vinny, you have any last words? Vinny does not. I will see you soon. Cheers.